Hello everyone, welcome. Today we're going to talk about transistor. The transistor is the electronic device. In your textbook, Form 5 textbook, the new syllabus, you can find it on page 187 until 192. But before that, before we can discuss about transistor, before we can talk further about transistor, I assume every one of you has already understand the semiconductor diode. Everyone of you know how the p-type and n-type semiconductor diode works. Only then we can talk about transistor. So now we're going to discuss further more detail about transistor. So what is transistor? So transistor is actually an electronic component that has three terminals, namely emitter represented by the capital letter E, and base terminal represented by capital letter B, and collector terminal represented by capital letter C. So there are two types of transistor. The first one, or one of those, is NPN transistor. Another one is PNP transistor. And as I said just now, what is N, what is P transistor, N-type and P-type transistor? I assume you already know previously. So to refresh your memory, so N-type and P-type actually is diode. It's made of the semiconductor diode. Okay. So why call NPN and PNP? For NPN transistor, the P-type semiconductor diode is sandwiched, is in between. Okay, sandwiched by the N-type semiconductor. Similarly, for the PNP transistor, the N-type semiconductor diode is sandwiched by the P-type semiconductors. So the structure of Pnp transistor. Take a look at this structure. So this N-type semiconductor diode and the P-type semiconductor diode, they are joined together in order to make transistor. So P-type for NPN transistor, the P-type semiconductor diode is put in between, in the middle of the N-type semiconductor diode. Together they form what's called the NPN transistor. So the N on the left is called collector. P in the middle is base, and N on the other side is emitter. Similarly, for the PNP transistor, N-type semiconductor diode is sandwiched in between. They form the base terminal, NC on the other side, the left, emitter on the other side, on the right. So the symbol for N transistor. So from the structure, we form the symbol. So this universal symbol. So everyone who study physics should know this is the symbol for the transistor. Okay, the first terminal at the top one is a collector terminal represented by letter C. Horizontal terminal on the left is base terminal represented by capital letter B. And at the bottom is the E, or emitter terminal represented by capital letter E. And the symbol for PNP transistor. Okay, so please take note. Okay, what's the difference between NPN and PNP transistor? Okay, for the NPN transistor, you see, notice that the arrow pointed toward the E terminal. The arrow is pointed now downward. That arrow shows the direction of the current flow. So for NPN, the current flow should be downward toward the E emitter terminal. Okay. So likewise for the PNP transistor. Here's the structure. Okay. So notice the difference between PNP and NPN transistor. For the PNP, the arrow is pointed upward, meaning that the current flow from bottom up. And NPN, the arrow pointed downward. Okay, so the current flow downward for NPN transistor. That is the difference in the symbol. So how can we use this NPN and PNP transistor in the circuit? We take a look. Okay, we take NPN transistor. Easier for us to understand rather than mix. Okay, for NPN transistor, when you connect them in the circuit, they will form two circuit. The other one is called base circuit, and the other one is called collector circuit. And please notice that the arrow for NPN, since the arrow pointed downward, so we know that this is the NPN type transistor. Okay, on the other hand, take a look at this PNP transistor. The arrow pointed upward, so does the terminal of the dry cell or the battery. Okay, the negative terminal should be toward there, then the positive terminal, the longer one, is at the end bottom compared to the PNP transistor. Sorry, compared to NPN transistor. Okay, so here is how to show you the diagram. The flow of the current in the collector terminal is represented by IC, or is a collector current. The current flow from the base terminal is IB. We call base current. And similarly, the current flow at the emitter terminal is called IE. So how does the transistor work? The transistor works in such a way that there must be a current flow in the base circuit, or IB must flow in order for the current to flow in the collector circuit, or IC to flow. If there is no current flow in base circuit, there is also no current flows in collector circuit. In other words to say, if IB is 0, therefore IC also 0. For this case, we said that this transistor is off. In contrary, if there's a small current flow in the base circuit, or IB is flow but very small amount of IB, then a bigger amount of IC will flow. This amount of current in the collector circuit, or IC, is much bigger as compared to the amount of current in the base circuit, or IB. So in this case, if IB is flow, then IC will flow. Therefore, this transistor we can say is on. The characteristic of this transistor in such a way that a small change in base current IB will allow a bigger current in the collector circuit IC to flow is very unique. Because of this transistor can be used as a current amplifier. Okay, so take a look at the terminal for the NPN. Terminal of the battery on the base circuit and the terminal of battery on the collector circuit. They must be in one direction. Otherwise, the circuit cannot function. Okay, so the base current flows from B terminal to the E. Only then the current from collector circuit IC will flow. Okay, let's say we close the switch or switch on. When the switch is closed, or you can say it's on, so there's a small base current flow in the base circuit. You switch on, this current flow on the base circuit. Okay, this small current flow in the base circuit can produce a minimum base voltage across the terminal B and E, or we call voltage BE. The voltage between terminal base and terminal emitter. Very small base. This small change in the voltage of the between base and emitter terminal, okay, will cause the current flow in the, because the current flow in IB and the base circuit, the collector current will flow. Okay, because the collector current flow on the collector circuit, therefore the bulb will light up. The bulb will light up. Okay, this characteristic is unique to transistor. Because of this, transistor can be used as a current amplifier. So if we change this bulb 2 with the speaker, so your voice will be louder. Because a small change in the base circuit will produce a very big change in the collector current. So therefore, for this case, transistor is used as a current amplifier. What happened to bulb 1? Bulb 1 is dim. Why? Because the resistance R1 is very high. The bulb 2 will light up brightly. Bulb 1 dim when you close the switch or you turn on the switch. Another function for transistor is it can be used as an automatic switch. Okay, but before you use this transistor as an automatic switch, there's some modification needed. Okay, for example, the 2 voltage supply just now from base circuit and collector circuit, we can combine them to form a single source. Another one, add another resistor, additional resistor. Now there are 2 resistors in series with the power supply. Okay, the purpose to add this resistor is to form what we call is voltage divider. So this voltage divider is used to control the minimum and maximum voltage that allow to control what is the minimum and maximum voltage to flow that can be used on our device. Okay, to make it clearer to you, here is the arrangement of the simple circuit when you use transistor as a automatic switch, whereby we add another one resistor, okay, this R1 to form the potential divider. Okay, here is the structure. So the voltage on the left is called voltage in, or the power supply. And the voltage between terminal B and E is called V out. Just now we have R2 and R3. Okay, now in order for the transistor to be what we call it automatic switch, add another resistor. Let's call it R1 here. Okay, so we can calculate the value of V out, V in, voltage supply, or whatever by using this equation. This equation is basically the ratio. Okay, the potential between the terminal base and emitter base terminal and emitter terminal to the potential difference across or the power supply, total power supply, is equal to whatever the resistor in that base circuit over the total resistor between base circuit and the terminal. Okay, let's say we want to use transistor as a light control switch. So in order to do that, we have to replace some of the resistor with the light dependent resistor. The symbol for light dependent resistor is there. See, there's a resistor in the circle. There are two parallel line to represent the light. Okay, so we replace R2 with the LDR resistor, light dependent resistor, LDR. So how LDR functioning as a light control switch? So LDR resistance is very high when the light intensity is low, and very very low when the light intensity is high. It's a reverse, okay? Contradict. So that's a special characteristic of the light dependent resistor. So because of that, in the dark, LDR or light dependent resistance is very high. Its resistance is very high in the dark. Therefore, the voltage across LDR will also increase. When the voltage across LDR exceeds the minimum voltage across terminal base B and emitter terminal E, the base current IB will flow. The flow of the current in the base circuit will cause the current in the collector circuit IC to flow. Therefore, the bulb lights up. That's the concept. Take a look. Okay. So far, I hope you understand what I'm talking about. So, hope everything is clear. Besides that, we can use transistor as a heat control switch. In order to do that, we need another resistor, which is called thermistor. Okay, so this thermistor, they work based on the temperature. Okay, here the arrangement of the circuit when we want to use transistor as automatic switch to alarm us when there's a fire, when the decrease change in the temperature in the room. We can set up this circuit to control the air conditioner, to control the fan. Okay, when there's a very hot, the fan or the air conditioner will automatically turn on. So in order to do that, we have to replace LDR with the thermistor. Here is the arrangement. So how does the thermistor work? Just like LDR, thermistor works in such a way that, okay, it resistance changes with its surrounding temperature. If resistance is high at low temperature and low at a high temperature as compared to the LDR, but LDR is based on the intensity of light, while this thermistor based on the temperature of the surrounding. So when its surrounding temperature increases, the resistance decreases. This causes the voltage across thermistor decreases. What happens when it decreases? Based on the concept of the potential divider, when the voltage across thermistor decreases, the voltage across resistor R2 increases. When the voltage across resistor R2 exceeds the minimum voltage across terminal B and emitter terminal E of the transistor, base current will flow. Therefore, the collector current IC also flow. As a result, you put alarm there, alarm will sound or a trigger. So in general, the minimum voltage for silicon transistor is 0.7 volt, and germanium based transistor that made of germanium, okay, is normally 0.3 volt. That is the minimum voltage. So I hope everyone understand. Okay, if you don't understand, you can refer to your textbook. Okay, in the textbook, a new curriculum, you can see this transistor they explain very clearly. Alright, to test your understanding, let's do this practice in your own. Alright, we'll take a look at this diagram. The practice number 1. The diagram below shows a transistor circuit. What is the value of V1 if the value of V2 is 4.5 volt? Okay, the question number 1. Question number 2. The diagram below shows simple transistor circuit. Okay, that's all. So the question is, name the type of transistor used. This is the structure question. On the diagram, label the base circuit and the emitter circuit. And C, draw the symbol of the dry cell at the Vs and Vc. You have to refer to diagram to see where is Vs, where is Vc. And the other one, D, what is the function of the resistor R? Practice number 3. The diagram shows a transistor circuit. Okay, they have the transistor. The question is, name the component P. B, state the potential difference across X, Z. And C, calculate the potential difference across component P if its resistance is 6 kilo ohm. And the next one, number 4. In that condition, the resistance of LDR is 1 mega ohm. To turn on the bulb, the minimum voltage across LDR is 2 volt. What is the maximum value of resistor R to turn on the bulb? Okay, these are the questions. Okay, you can pause it now, do the question or review before you look at the answer. I suggest to you, don't look at the answer first. You try your based on your own understanding, then you can check your answer. So for the answer for number 1, back to question number 1. So in order to answer that question, we have to use the potential or voltage divider method, whereby the voltage between the two terminal or transistor, resistor, the same as the total voltage supply. So if V2 is given as 4.5 volt and the total voltage is 6, therefore V1 is 6 minus 1.5 volt, which is equal to 4.5, which is equal to 1.5 volt. So the type of transistor used based on the diagram is because the arrow is pointed downward. Therefore, it is NPN transistor. So they asked to label the terminal of the voltage, the cell, dry cell. You see, the positive terminal should be in such a way that it allows the current flow through the C terminal on the collector circuit. The same with the base circuit. The positive terminal should allow the current to flow, okay, from B terminal. If you reverse this, either one or two of these terminal of dry cell, then the circuit is off. Okay, so what is the function of the resistor R here? Resistor on the base terminal is to limit the current flow to transistor. In other words, to control the current flow through the transistor. The answer for okay. The answer for question number 3, what type of component P is simple. You know that is a thermistor. So what's the voltage? Is the same as the voltage supply, 9 volt. So in order to answer the question C, you use the formula for the potential divider, which is the ratio. Okay, what is the potential across XY? We know that the total voltage is 9 volt. So the potential across the XY over 9 volt is equal to the resistance across XY, which is 6 over the total resistance from X to Z, which is 6 plus 10. Okay, so use the calculator, you should get the answer 3.375 volt. The answer for number 4. Okay, what we know from question number 4, the resistance of LDR is 1 mega ohm. The minimum potential difference across LDR given should be is 2 volt. The voltage supply is 12 volt. So in order to answer this question, we use the potential divider method. The potential divider method is stated that this use the ratio of voltage and resistance. The voltage of LDR over the total voltage supply equal to resistance of LDR divided by resistance of LDR and resistor. The ratio voltage and resistance. So use the formula. Given that the LDR voltage is 2 volt and the resistance is 1 mega ohm, okay, but we don't know what the resistance of the R or the resistor. Use the formula, you should find this number 5 mega ohm is the maximum resistance of resistor R. So I use this R to represent the resistance of the R, resistor R. So I hope you understand what we discussed today. You can go through this video one more time or several times, up to you. Then try to answer the question. So this is the example of the question, the common in the exam. Okay, so hopefully our discussion will benefit you, and I wish you all the best for your coming exam or in your study. Thank you very much for your attention.